Hi guys, today we're going to learn about the integral test. In this lesson, we will discuss a very simple but powerful idea. In order to prove that certain series converge or diverge, we may compare them to integrals. So, this is the integral test. Suppose that for all the x's greater or equal than 1, the function a of x is continuous, positive, and decreasing. Please note that this 1 that you see here, it's the indexing that you have here, okay? So consider the series and the integral, first the series from k equals 1 to infinity of a sub k, and the integral from 1 to infinity a of x dx. Please note that what you have is, this is the lower limit and this is the upper limit or bound, okay, however you want to call it. They need to match, where a sub k is going to be equal to a of k for integers with k greater or equal than 1. If this one diverges, then so does the other, okay? If this one converges, so does this one. If you remember from improper integrals, you know that this integral will diverge if you have infinity, negative infinity, or does not exist. So let's do some examples here so you can see how simple is the situation that we have, okay? So over here, the first thing that you need to do is to prove the three conditions that we have. The first condition that we have is if f is continuous, right? So f is continuous, okay, on the interval 1, infinity. Do you agree with that? What is f? F of x is going to be equal to 1 over 3x plus 4. So you can see that the problematic point here is going to be negative 4 over 3, which is not part of the domain that we're analyzing. Why we're analyzing this domain? Because that's going to be pretty much what you're analyzing here on the series, from 1 to infinity. That's why. Okay, so condition number 2 is f positive on the interval? F is positive, okay, on your interval 1 infinity. Why? Well, plug some random numbers. If you plug 2, this is positive. Positive divided by a positive, you have a positive. If you plug a million here, what happens? You still have a positive number. So number 3, what's the business here? For number 3, what you have is if f is decreasing on the interval 1 to infinity. So ask yourself, what's the business here? As x increases, then the denominator will get bigger and bigger. So what happens here is that your function will be increasing. In case that you are second guessing yourself and you don't know what's the business, you can always take the derivative of this one, and if the derivative is negative, which will be in this interval, then it's going to be decreasing. So you have the three conditions, so you can apply the integral test. Okay, so apply the integral test. So what is the integral test? What you have in the integral test is you are going to have an integral, okay, that is going to be from 1 to infinity, and then you are going to have that it's 1 over 3x plus 4 dx. So here the first thing that you need to have is good notation. For the good notation, you know that we need to change that infinity to the limit because you have an improper integral. So let's call it c approaching to infinity. So you have the integral from 1 to c of 1 over 3x plus 4 dx. And then what you have is you just find the integral of that situation. As you can see, I would do a pretty quick use of. Okay, so you can see that u is going to be 3x plus 4, having your du being 3. So you need to complete that 3, so you have a 1 over 3 here. Therefore, you have a natural log of absolute value of 3x plus 4. Close it. Then you have that your limits of integration are 1 to c. Okay, now what are you going to do? You are going to substitute your x for the 1 and the c. So you have the limit when c approaches to infinity, 1/3 times natural log of absolute value of 3c plus 4 minus natural log of what's that? You plug the 1 here, so you have 3 plus 4, that's a 7. Okay, close it. So what happens here? Let's analyze the situation that you have. You have 1/3, which is fine. Then when you substitute the c for the infinity, what do you have here? This flies to infinity. This is a number. So, but overall, you know that this is infinity. Since it's infinity, you know that that integral is going to diverge. Therefore, what can we conclude? The series diverges by integral test. Okay? So for this example, what you have is the summation from n equals 1 to infinity of n divided by n power 2 plus 1. So the first thing that you are going to do here is you are going to let your f of x or a of x or however you want to call it, x divided by x squared plus 1. Okay? So then you set your three conditions. Okay? So first ask yourself, is f is continuous? Okay? On the interval 1 infinity. Why? Because you have that the indexing is 1. And the answer is yes. What's the problem here? Nothing. Okay, you actually don't have a problem, so check mark. Condition number 2 is f positive. Okay, on the interval 1 infinity. Ask yourself, if you have a number between 1 and infinity, what do you have? Positive divided by a positive, that's a positive. Okay, and then the third condition that you have over here is f decreasing, okay, on the interval 1 infinity. So which one grows faster? The numerator, that it's just x, or the denominator, that it's x squared plus 1? You can see that the denominator is growing faster than the numerator. Therefore, you have that this function f of x is decreasing on the interval 1 infinity. Therefore, you can apply or happily your integral test. Apply integral test. So what's going to be here the business? You do your integral from 1 to infinity because you copy paste the 1, copy paste the infinity. Okay, so what do you have here? X divided by x squared plus 1 dx. So you can see here a beautiful u substitution, right? So you have that u is going to be what? Technically speaking, you have u is going to be x squared plus 1, and your du is going to be 2x dx, right? Clearly you don't see the 2, but don't worry. What are you going to do? You are going to divide everything by 2. So you have that this is going to be equal to the limit when c approaches to infinity, using correct notation, from 1 to c, and then you have x divided by x squared plus 1 dx. Then you use the u solve that we just mentioned, so you have the limit when c approaches to infinity. And what do you have here? You have the 1/2, right? And then you integrate that. What's going to be the integral of that is going to be natural log of absolute value of x squared plus 1. Okay, from 1 to c, and then you have that this is going to be equal to the limit when c approaches to infinity of 1/2, and then you have that it's going to be natural log of c squared plus 1 absolute value minus natural log of, that's going to be 2. Okay, so obviously this will fly to infinity, so you have that this is going to be infinity. Therefore, what can you conclude here? The series, okay, specifically this series that you have over here, diverges, okay, by integral test, okay, by the integral test. Okay, the example that we have over here tells you to find if the series from n equals 1 to infinity of 1 over n to the power of 3 converges or diverges. So what are we going to do here? What you're going to do again is you're going to let your f of x, in this case my f of x, I'm going to call it 1 over x power 3. Okay, and then you're going to check your conditions. Condition number 1 is f, okay, what do you want first? F is continuous, okay, on your interval 1 infinity. What do you see here? The problem that we have is at 0, and that's not part of the interval, so we are very happy. Check mark. Okay, therefore, second condition, f is, what was my second condition here? Is positive, okay, on your interval 1 infinity. Okay, so if you plug positive numbers here, because those are the numbers from 1 to infinity, what happens there? You get a positive number. Yay. Okay, so third condition, f is what? Decreasing on the interval 1 to infinity. Okay, so you can see that this, it stays constant, and this one increases without a bound, therefore it's going to be decreasing. Let's say hypothetically that you are in the AP test second guessing yourself. What are you going to do? You take the derivative of your f of x. What's the derivative? You know that the derivative of the situation is going to be negative 3 divided by x to the power of 4. Okay, so if you have this, you can see that clearly this is a negative number because whatever you plug here is positive, so this is less than 0. If the derivative is less than 0 when you plug numbers from 1 to infinity, then you know that it's decreasing, okay? So that's in case that you are starting to second guess yourself, okay? So we can apply the integral test, right? So you apply the integral test, okay? We integrate from 1 to infinity because that's the indexing that we have here, okay? And then you have 1 over x to the power of 3 dx. So you get your beautiful notation with, let's call it c, 1 to c. And then you have that it's 1 over x to the power of 3 dx. So when you integrate that, what's going to be the business? This is as having x to the power of negative 3. So you have that this is going to be the limit when c approaches to infinity. And then you know that that is going to be x to the power of negative 2 divided by negative 2 and evaluated from 1 to c. Okay? So rearranging this with your super algebra 2 skills, what do you have here? What we have is you have negative 1 divided by 2c squared plus 1/2. Do you agree with that when I plug the 1 here and when I plug the c? Okay? So you are like, now what's going on? Okay, so this one is going to be a negative 1 over infinity, which that one flies to 0. This one stays as 1/2. So this is going to be equal to 1/2. Therefore, what happens here? Thus, the series, okay, converges, okay, by the integral test, okay. So you can see that the number that you get is a real number, okay. So here it's a number, okay, finite number. So therefore it converges, okay. Now we have a little here FYI, okay. So the integral test is powerful, okay. So we know that if the series converges, like this one, okay, the following inequality will be true. What this tells you is that the integral from 1 to infinity of a of x dx, in our case f of x, is less than the summation from k equals 1 to infinity of a sub k, or a sub n, whatever you want to call that, the indexing, okay, is less or equal than a sub 1, which is the first term, plus the integral from 1 to infinity of ax dx, okay. And by the way, you have here the reminder that we're going to talk about that later in life, okay. So that's what we call the reminder, that's what we call the r. But what we're going to focus right now, it's in this part, okay, the part that we have here, okay. So they tell you, use your answer to example 1c and the integral test to find an upper and lower bound, okay, of the limit of the series, this one. Please note something. Some students, they say that because this is equal to this, then the series converges to this. That's not true. You don't know that, okay? So do not over conclude there and be careful, okay? So what you know is that you can find a neighborhood, okay, thanks to this, where the series will converge, okay, but you don't know where it exactly converges, okay? So what are you going to do here? What you have is that, technically speaking, my f of x that I have, that it was your 1 over x to the power of 3, which it was a of x, okay? By the way, okay, so to translate these terms exactly like we have it here. So you have that 1 over 1 to infinity of a of x dx is less than the summation. In this case, we have that it's 1 over n to the power of 3 from n equals 1 to infinity. It's less or equal than a sub 1 is the first term, plus the integral from 1 to infinity a of x dx, right? So now ask yourself, do you have the first term? What's the first term? We don't have it, but we can find it, right? So you have that the first number here is a 1, so plug the 1, so you have that this one is a 1, okay? So we have all the pieces of the puzzle. Do you have the value of this? Yes, you do. That's 1/2, okay? You have that that's 1/2. So you have that it's 1/2 is less than, okay, your series, okay, the one that we're looking at, this one, less than 1 plus 1/2. So pretty much what you have here is something very powerful, okay? So what you have here is 3 over 2 and then 1/2. So what we have here is that your lower bound, what's going to be the lower bound? The 1/2. And the upper bound is going to be 3/2. What this is telling you? It's telling you that this series that we have in the middle, it's going to converge somewhere between 1/2 and 3/2. Are we okay with that? That's what you know, okay? And that's true, okay? So that's for that. I hope that you find this video helpful. Bye!